All right, we're going to move on to section 8.2. This is dealing with series. So let's look at these first three, because I'm going to employ a method that works for all of these, right? So if you just watched the previous video or did the previous review worksheet, you'll notice that every question on this review is just a summation of the previously defined sequence. So if we know that the limit of this sequence approaches 1, or even a number larger than 1, well, you can imagine, right, if we define what a summation is. So the first term is going to be a sub 1 plus a sub 2 plus a sub 3 plus dot dot dot. And we evaluated that the sequence is going to veer to 1. So by the end of this is going to be a sub infinity, right? It's going to be 1 plus 1 plus 1 plus 1. And what does that do over an infinite amount of times? That verges to infinity. So for these three questions, what I'm doing is evaluating the sequence, seeing if it converges. If it converges to a number that is 1 or greater, this is like our R, right? Then we know that the series is going to diverge because we've evaluated what the last terms are, right, in a sequence when we take the limit as n approaches infinity. We're evaluating what the last term of this series is going to be. In essence, that's what we're doing. Because we're saying, well, n is going to be infinity, and that's what the top is. So for each one of these that evaluated to a positive number, or even a negative number, I guess, right? Because this one would be negative, but it's the absolute value of it is still larger than 1, which means that the series diverges. So just to demonstrate this one more time, I'm just going to plug dummy values into this first one. So with n equals 1, we'll get 3 times 1 plus 1 over 3 times 1 minus 1. So that's going to be 4 over 2, which is equal to 2. So n equals 1 is equal to 2. Then we're going to add n equals 2, which is going to be 3 times 2, which is 6, plus 1, which is 7, over 6 minus 1. So this is equal to 7 over 5. 7 over 5. So now we're going to do n equals 3, so that'll be 9 plus 1 is 10, over 9 minus 1 is 8. So this is equal to 10 over 8, which is 5 over 4. Then let's plug in 4. It's going to be 12 plus 1, which is 13, and 12 minus 1, which is 11. It's 13 over 11. And as you continue down this, it's going to get closer and closer to 1 plus 1 plus 1 plus 1 plus 1. And once you add all these together, it's going to be a very large number. So it diverges to infinity. So that's how I approach those ones. Let us move next to this question. So we already figured out that a sub n is equal to 3 over 3 to the power of n, right? So let's plug in n equals 1 here. N equals 1 is going to be equal to 3 times 1/3, which is equal to 1. Then we're going to add n plus 2, or n equals 2. And that is going to give us 3 over 9, which is equal to 1/3. As we continue down this path, we'll get, 3 over 27, which is 1/9. and then 3 over 81, which is 1/27. So you can see a common value in this, right? We're going to employ the method A over 1 minus R, right? This is a formula to see where a series converges. Only the absolute value of R is less than 1. This can also be seen as R is greater than -1 and less than 1. That's what absolute value is. So A is our first term, so that's just going to be 1. So let's write the equation over here. So A is 1 over 1 minus R. What is R? What is the common term here? Well, this is 3 times 1/3. This is 1/3 times 1. This is 1/3 times 1/3. This is 1/3 times 1/9. So the common term here is 1/3. Another easy way to see that, if we go back to our original equation, that we have some number times this, you see. So this is going to be the common ratio that's being multiplied each time, and we're just multiplying by 3. So let's work through this equation. This is going to be 1 over 2/3. I don't know about you, but my algebra brain kind of checks out when I see something like this. It's actually very simple. So we know the fraction 2/3. If you put that on the denominator, it's just taking the inverse of that. And when you take the inverse of a fraction, it's just flipping it over, okay? Some of you might already know this. I hope you already know this, but you know, when it comes to crunch time, you're so worried about the calculus stuff, your brain's in calculus mode, you forget the easy steps like this. So the behavior of this series is that it converges to 3/2 by this formula after we evaluated what the first term was, that's our A, and then the common ratio, which is our R. Let's look at the next question here. So we can see that our common ratio is going to be equal to 1. Oh, that doesn't work because it needs to be less than 1, right? If we plug this into the equation, we'll get 1/2 over 0. That doesn't work. So we can tell by this test immediately that it's going to diverge. And if you plug in values of n, that's going to make sense, right? 1 to the n is always going to be 1. So this is basically just 1/2 plus 1/2 plus 1/2 plus 1/2 forever and ever, veering off to infinity, because this is already 1, and then it's going to be plus 4 more of those, which is another 1. So you can think of it as 1 plus 1 plus 1 plus 1 plus 1. So that diverges to infinity. All right, let's look at, these are the last two. I'm just going to post one at a time because they are going to be different methods. But we're still going to use this A over 1 minus R formula. So we have the summation of n equals 1 to infinity of 5n plus 2 over 6 to the power of n plus 2. So one thing I want to notice here is this, right? I want to get this to a r to the n value so that I'm able to use my formula, right? So what does this plus 2 mean? I'm going to show you something that I did at first, which is incorrect. If you rewrite it like this is actually equal to 5 to the 2n over 6 to the 2n. So that's incorrect. When you have an exponent to the power of an exponent, you multiply them. So what instead we're going to do is multiply them. If you multiply two values that have the same base, then you add the exponents. If you put them to the power 2, you multiply the exponents. So I'm going to multiply 5 squared over 6 squared to get 5 over 6 to the n. See how this makes sense? If we multiply 5 squared to 5 to the n, that's going to give us a 5 to the n plus 2. 6 squared times 6 to the n is going to give us a 6n plus 2. So once we've done that, once we've rewritten it, it's very clear to see that r is equal to 5/6, and the absolute value of r is definitely less than 1. Let's get our a value by plugging in the first term. So n equals 1, that is going to be 5 over 6, right? And then we're going to multiply it by 25 over 36. So it's basically just 5 cubed over 6 cubed, which is 125 over 216. So if we plug that, our a and r values into our beautiful equation, we're going to get 125 over 216 divided by 1 minus 5 over 6. And this is equal to 125 over 216 divided by 1 over 6. This is another algebra step where we're going to multiply by the reciprocal. So it's going to be 125 over 216 times, we're going to flip this over, right? 6 over 1. So you can imagine just picking this up and flipping it over. 125 times 6 divided by 216 is going to be equal to 25 over 125 over 36. And this is our answer. So the series converges to 125 over 36. Happy days. And for our final review question, we have the series of 3 to the n plus 4 to the n all over 7 to the n. So the first thing I'm going to do is recognize that this fraction is equal to this, right? They have common bases. The numerator is just addition, so we can split them apart. And that means this is a property of the summation. That means that these are equal to each other. This and this, oh, it's 1, is equal to each other. And that makes it pretty simple because we have our r values defined here. We can plug in 1 to get our a values and solve. So I'll humor you to try this for yourself, and then I'll go through it right now. So pause the video if you want to try it. So our r value for this is going to be 1, this is going to be 2. Our r value for the first one is 3 over 7, and our a value is 3 over 7. Our r value for the second one is 4 over 7, and our a value is 4 over 7. Notice that r is less than 1 for both of them, so that is good. So let's plug it into the equation. 1 minus 3 over 7 is equal to 4 over 7. We're going to add 4 over 7. 1 minus 4 over 7 is 3 over 7. So let's see what this is equal to. It's going to be 7 times 3 over 7 times 4. So that's 21 over 28 plus 7 times 4 over 7 times 3 is 28 over 21. Let's see what that is equal to. 28 plus 21 is 49. Divided by 28 plus 21 is 49. That seems incorrect. Let me try this again. I don't want to leave you off on a cliffhanger. You know? make mistakes. It helps us learn. I'm glad I'm doing this review because I'm not an expert, and it helps me figure it out just as much as it helps you guys figure it out. So let's rewrite this again. This is going to be 3 over 7 to the n plus 4 over 7 to the n. And they both have this summation here starting at n equals 1. The first one, r, is going to equal 3 over 7. And when we plug 1 into this series, our a value is going to be equal to 3 over 7. For the second one, our r value is equal to 4 over 7, and our a value is equal to 4 over 7. So let's plug it into the equation. I must have just screwed up some algebra somewhere. Plus 4 over 7 over 1 minus 4 over 7. Maybe you guys can catch that in the video. But otherwise, we're gonna use the same method as the other one. We're just splitting it into 2, so we just have to do it twice and then add the results like this. So this is equal to, so this is 4 over 7. And 7 times 3 is 21, and 4 times 7 is 28. So 21 over 28 is 3/4. So the left side is 3/4. And then we're going to add 4 over 7 divided by 3 over 7, which is 4 divided by 7 divided by 3 over 7 is 4/3. So if we add those together, it equals 25 over 12, right? We multiply by the common bases. 4 times 4 is 16, 16 plus 9 is 25 over 12. So this series converges to 25 over 12. And that is the end of our thing. Oh, that's where I went wrong. I didn't multiply by common bases. I just added 4 plus 3 over 4 plus 3. So of course that's going to equal 1. What a silly mistake. See what I'm saying? You put your brain in calculus mode and you forget all the algebra. That's where the most important part comes up. So hopefully this example will remind you not to make such foolish mistakes in your upcoming exams. Thank you very much.